Well, hello, you're still with me. AB video 5.3, derivatives of inverse functions. Okay? All right, so here's what's going to happen. They're going to give you a function f of x, but they're going to ask you for the derivative of the inverse function at a particular number. Now, first thought, you would think, okay, I'll just find the inverse function, then find the derivative of the inverse function and plug in x equals 5. Reality is you don't need to find the inverse function, and you're under the impression you always can find the inverse function, and that's sometimes impossible to do. Okay, so here is a formula that you will use, and you will never have to find the actual inverse function. The derivative of the inverse function of some function f at d is equal to 1 over the derivative of the original function at c, where f of c is equal to d. This all comes down to the whole idea that what was x becomes y, what was y becomes x. That's what inverse functions are all about. So if you think about this, you're taking 1 over f prime of c, where f of c is equal to d. If the point CD is on f, that means the point DC is on the inverse. And so I'm using the y coordinate of the inverse in effect. All right, so some reasons why this all works. If you think of y equals f of x, then dy dx is f prime of x. If you think of x as a function of y, because if you have x is the inverse function of y, I can think of that as a function of y. If I take d dy of each side, I get dx dy equals the inverse function of g at y. This is what really should make sense to you, is that just algebraically that dx dy should be the same thing as 1 over dy dx. Well, my dx dy is g prime of y. My 1 over dy dx is my 1 over f prime of x. Okay? So basically, I'm just trying to explain to you where the formula comes from, but really, you just need to memorize the formula. They're going to give you an f of x, and they're going to say, evaluate the inverse function of that function at x equals d, let's say. And all you have to do is 1 over the derivative of the original given function f at c, and you will start by finding out where f, the original function f at c, is equal to d. So you'll set f of c equal to this d and solve for c. Let me show you. It's not complicated. Okay, now instead of d, they're going to call it a, whatever. There's only a few questions that you're going to do from here. They do a lot of review of exponentials and inverse functions. I'm just concentrating on the calculus. Okay, so here's an example. F of x equals 1 over 27 times x to the fifth plus 2x cubed, and d, which they call a, is negative 11. So the question is, find the derivative of the inverse function of this guy, not the derivative, but the inverse function of this guy. Find the derivative of the inverse at d equals negative 11. So my formula is that the derivative of the inverse function of f at d is equal to 1 over f prime of c, where f of c is equal to d. So my d is negative 11, so I'm looking for the derivative of the inverse function of f at negative 11. Now that's supposed to equal, according to my formula, 1 over f prime of c, where f of c is equal to my d. But I know what f of x is, so I know what f of c is. F of c is this same function with c's instead of x's. I set that equal to negative 11, and then you would have to use your calculator here, for God's sake. You'd get c equals negative 3. You come back over here, replace c by negative 3. And now all you have to do is figure out 1 over f prime of negative 3. Well, if you have f of x, its derivative is that constant times 5x to the fourth plus 6x squared. And we're just going to replace all those x's by negative 3's, and we will get our answer. Here's another example. Remember, this is our d. F of x equals 5 minus 2x cubed. The question is, find the derivative of the inverse function of that f function at a, where a equals 7 for us, that's d. So here's our formula. The derivative of the inverse function of f at d is 1 over f prime of c, where f of c equals d. In our case, our d is 7. Our f of c is 5 minus 2c cubed, so I'll solve that. That'll give me c equals negative 1. So that becomes 1 over f prime of negative 1. Well, if f of x is 5 minus 2x cubed, then f prime of x is negative 6x squared. So I have 1 over negative 6 times my negative 1 squared, and that'll give me an answer of negative 1/6. And here's one last one, and then we're done with this video. F of x equals the cosine of 2x. Now they're going to have to limit that for you. X is between 0 and pi over 2, and a is 1. Again, the question is find the derivative of the inverse function at this number a, okay, which we call d. So we know that the derivative of the inverse function at d is 1 over f prime of c, where f of c equals d. So my f of x is cosine 2x, my f of c is cosine 2c. D was given to me, that's the a, that's 1. The cosine of what kind of an angle will equal 1? Well, the only one between 0 and pi over 2 would be at 0 radians. Whereas if they didn't have this, it could be at 0 radians. It could also be at 2 pi radians and 4 pi radians and 6 pi radians and negative 2 pi radians, but this here limits it to just one answer. So it turns out that when d is 1, c is 0. So I come back over here. I have 1 over f prime of 0. Of course, I'm going to need f prime. If f of x is cosine 2x, f prime of x is negative sine 2x times 2 by the chain rule. So I take that, replace the x's by 0, and I actually find out that this derivative does not exist. And that's